RoboPapa.
Hey guys, RoboPapa here. It's been a while, I know, but here we are again. Hopefully you guys are all good and healthy and staying safe with everything that goes around. So today I want to do a very simple video showing how you can actually build your own joystick controller that can control a different device. In my case, it's a tank. You can probably see a demo here, maybe. And I'll show you how I code it and a little bit of the schematic. So let's get started. Alright guys, so this is how the robot is. Very simple. And we have the tank itself, as you saw from the video, that some of his wheels are actually lifting. And then there's the joystick that I've created as well. So let's go on through the components over here. What we have is the Arduino Uno on the bottom. And on top of it, it's just a shield, motor shield from Adafruit. And I will leave the link for it down in the description below. We also have the NRF radio transmitter, excuse me, that gets the signal from the controller, the joysticks themselves. I added over here like a power button so I can actually start and stop it. And it goes through a battery pack over here with that barrel, the jack barrel. The robot itself, the tank itself, has encoders which are not actually attached to it, but you can actually do that and then know how many revolutions you have. I just didn't use it over here. And the wheels that actually lifting is right over here. It's attaching to one of the servers. And then the motors themselves are over here in the back, connected to basically M3 and M4. I don't think you can actually see it very well. I'll try to leave a schematic in the description, a link to the schematic in the description below as well. So all that actually happening here is the controllers over here sending a signal with all the values that needs to be sent to the receiver over here, and then the code in the Arduino is actually interpreting the values to know what movement it is. We'll go through the controller right now, and then I'll show you the code and it will make more sense. But it's very simple schematics or design over here. As far as the controller, it's very simple as well. All it has is over here is the NRF to send the values. Two joysticks that actually are with a push button, each of them. And we have the Adafruit Trinket Pro over here that is connecting everything. And in the bottom, there's the battery and the adapter for the NRF receiver. So you don't necessarily need to attach all the wires. And it's difficult to see all the wires that actually goes around, but it's fairly simple. What I have is the same as over here, and all the pins that are connected from here are going to pin over here. It's 5, 6, 11, 12, and 13, and over here it's actually 9 to 13, and are connected via these wires over here. Yeah, that's basically all it is. I'm leaving over here the port to be able to connect it, and if I need to change the code, it's accessible to it. But really this controller, you can use it to anything, not just necessarily this robot. All it does, it's actually looking into the values of each joystick, including the push button, and it's sending those values, so basically 6 different values. The value of left and right, so 0 to 124, up and down 0 to 124, and then a boolean of push button, and then you have 2 of them. And it sends through that, and the robot itself is actually accepting it. So let's go through the code right now, and hopefully it will make more sense. Alright guys, so here we are going to look into the code right now. So let me launch Visual Studio Code. And what we have here is the folder for the receiver and the transmitter. And we will start with the transmitter side of things. That's basically where our joysticks are sending their value. Just as a reference, I use this webpage, which I will leave into the description below, a link to it, where I used to understand as well as set up all of the pins for the NRF. There's a really nice diagram over here that you can actually use. So I set up over here a couple of defines, the chip enable and the chip select not for 9 and 10, but you can select anything that you want. I set up the push button to be basically pin number 5, joysticks left and joystick right. That's basically, we have the two joysticks. So like I said, the push button is number 5, the left vertical, it's A0, and the left horizontal will be A1. And for the right side, the push button will be on pin number 4, and then the vertical will be A2, and horizontal will be A3. I also had a LED connect on pin 6, but I haven't used that. We set up the pipe, and this is just a string that you can actually put into, and on the receiver side, they will need to use the same string on that. So if you need to send information to different receivers, you can. And that's the pipe over here. So we'll start with initializing the radio with the chip enable and the chip select not pins. And then I define the structure over here for the a joystick. So vertical position, horizontal position, and then the button itself. And I call it as a joystick. And I have 2 of them. Part of the setup is just basically the push buttons, and I use the input pull up. And this is important because that means that on a normal, so if the push button is not clicked, the value will be high. And when they're clicked, it will be low. And we'll see how we're using it later. And this is just for the serial output, so you can debug it as you program. I'm initializing the radio, and I open the writing for this pipe, so the 00006. And I'm not listening. So I'm telling over here the NRF that is actually only for transmitting the data and doesn't need to accept any incoming data. And then obviously the connect LED, which I said I'm not using. So the loop is very simple. Every iteration, picking up the 6 values for the 3 for the right and 3 for the left, digital read for the push button, and then analog read for the horizontal and vertical, and the same thing for the right joystick. Simple outputting of those values over here, just to see how that it's actually transmitting or receiving them. You can make it as big or small as you want. And over here, you can see that I use the push button. And this is where I said that it's important to note it's a pull up, because when it's high, I'm actually sending a false, which means that the button was not pushed. But if it's low, that means it's pushed. I'm sending true into the joystick. And I'm filling in the positions for joystick, the one joystick and the second joystick. So the right joystick and the left joystick. And then I'm transmitting that information by using the joystick structure, the array over here, and I'm sending the number of bytes depending on the size of the joystick itself times 2. So that is basically the transmitter. So if we go to the receiver side of things, over here it's a little bit, we got some extra stuff. We have the NRF setup, as well as the server setup, as well as the Adafruit. Because I'm using the shield for the motor from Adafruit. Over here, the chip enable, the chip select not, I actually set it up on 5 and 6, and the reason is that the servo is actually using I believe pin 9, so I couldn't use that pin over here. And as you can see, I just set up a left joystick and a right joystick definitions. The server pin is number 9, and I just defined as a break is 0 over here. I'll set up over here a motor shield. So this is how we're starting the motor shield. And I'm pointing to the left motor and the right motor. And those are basically number 3 and 4 on the motor shield itself, as I showed you in the video earlier. What I did over here is just the lift up servo, and that is where the extra wheels are actually going up or down. That's that servo. Here is the transmitting pipe. That's the same value as you have over here in the transmitter. And that's important. Otherwise, they will not know that you're communicating with them. And we initialize the NRF radio. Same structure as before for the joystick, the vertical, horizontal, and the button itself. And then I'm assigning 2 of them. If you have more than 2, I'm not sure why, you can increase it. If you have only 1, you can decrease it. And then I'm setting up some variables over here to know if I press the button, if I release the button, and what direction I want to go. And the lift up, it's really just because I'm using the same joystick to do the lift up of the extra motor. So I just needed a variable to know that. I'm setting up some the radio to begin, and I'm start listening. So this is the area where you're actually listening to it. And just initializing the lift up servo and then the motor shield itself. So really all I'm doing is that if I have a radio that's available, I'm start reading those values and calling different functionality. This is a different business logic. Checking if I have a lift up or not, and if not, then I process the movement. If I have a lift up, we will show that it's actually stopping and then do the lift up. And then if I initialize the debugger over here, which I didn't, then it will actually output to the serial log that this function will call. Initially, I was doing a delay just that I'll be able to see how it behaves, but you don't want to do a delay, so you can actually receive all the values right away and process them. And the done is if the radio is not available anymore, the done will be false, and therefore it will actually stop over here, this function. So if we go to the process the movement, really we're reading the position of each joysticks. We're getting the direction and we're getting the speed out of it. And then we're setting the speed and we're running the motor. So the left motor, the right motor. The direction, what I set up is if the value is less than 512, because the joystick itself in the center will be 512, and then on the left it will be 0, the right will be 1024. So if it's less than 512, I want to move backwards. If it's greater, I want to move forward. So what I did with the receiver over here is the joysticks, the 2 joysticks, are actually moving each motor. The one on the right is moving the right, the one on the left is moving the left. That's why you can actually, as you saw in the video, the tank was moving or rotating in place instead of going in a circle, just because the 2 motors can move independently. The speed is similar thing, depending on the direction. So if it's forward, I'm actually mapping the value from 512 to 1024 to be 0 to 255. So 0 is basically stop, 255 is going forward and full throttle. If it's a reverse, I'm going from 0 to 512, where 0 will be the 255 and the 512 will be actually a braking. So just in a reverse order over here. And that will be true for either the left or the right motor. When we have the lift up, so that wheels, the extra wheels that are actually going up, I'm stopping the motors and I'm releasing them. So the tank will actually be in a stopping position. And now I'm actually reading that value of how do I want to lift it up. And that is the speed that actually it's going. So every single iteration that I'm moving, I'm actually reading the angle and then I'm increasing it by a ratio of that speed. So it's not just going immediately all the way or all the way down, all the way up, all the way down. and then I'm writing that angle. So in order for us to stop, you need to press the button again, and that's where it's actually coming over here, and it set up the value to be released. And then it's not on lift up, and therefore it will start processing the movement. So that's really it, and this is just the print value, which is the same thing as we saw before. So that's really it. This is the receiver and transmitter. Why don't you leave some comments below and tell me how would you use this kind of functionalities, and how would you use the joystick paradigm or the joystick project for your own good. So if you like this video, leave a thumbs up. If you have any questions or concerns or want to know some more information, leave a comment below, and I will try to answer as soon as possible. Oh yeah, and don't forget to also press that bell so you can get the notification for future videos. All right, guys, thanks.